Hello, this is FlippedHarber for Precalculus. In this video we're going to cover section 6.4, product to sum and sum to product formulas. So again, you should be pushing the pause button sometimes and writing some equations down in your notes. Alright, our objectives for this lesson are to express products as sums and to express sums as products. We're going to do that in this video by looking at the product to sum formulas and the sum to product formulas. Then we're actually going to use them. We're going to express a product as a sum and express a difference as a product. Remember, a difference is just a different kind of sum. And then we're going to end by establishing an identity once again. Okay, so let's get started. First of all, here are our product to sum formulas. Now what this means is we have a sign times a sign over here on the left side. So this is the product side. And over here it's equal to a sum, or technically it's equal to a difference in this one. And you'll notice that this cosine is operating on one angle. Okay, this is one angle that we need to figure out. One angle over here. Again, same thing. A cosine times a cosine, we can express that as a sum of two different cosines. And then lastly, we have a sine times a cosine. We can split that up and make that a sum of two sine functions. Okay, I hope you push that pause button because now it's time to move on. Alright, so here's our sum to product formulas. So over here it starts with the addition or the subtraction of sines and cosines, and over here on the right side of the equations it's multiplied. So it's 2 sine times cosine. This is our angle here, alpha plus beta divided by 2. So you want to go ahead and add the angles and then divide by 2. That's what this sign is operating on. Same thing here and all the way down. You want to make sure that you take this difference and then divide by 2. And this whole mess here is the angle that this cosine is operating on. Alright, why don't you go ahead and hit pause and write these down. Alright, I hope you did it because we're moving on. So now I want to go ahead and express this product as a sum containing only sines and cosines. Okay, so that's going to be pretty straightforward because those equations that we saw only had sines and cosines. So I need to just pick out the proper product to sum equation. So I want to pick out the one that was cosine alpha, cosine beta, and that's equal to 1/2, and then the cosine of alpha minus beta. Now, does the order matter? Well, no, not really. It really doesn't, because I could switch these two cosines up and I could have cosine of 4 theta minus times the cosine of 3 theta. So it really doesn't matter which one's alpha, which one's beta. I would suggest that you stick with it the way it is, but you can always use the even and odd properties to straighten it out later. I'll show you what I mean. So I'm going to go ahead and plug in 3 theta as my alpha, 3 theta is my alpha, and that 4 theta is my beta in both cases. I'll go ahead and do some simple simplification, and I get this cosine of a negative theta. Now, cosine is an even function, which means that this negative really isn't doing squat for us. So let's just get rid of it. So here's what they want. It's a sum, okay, see the addition, of only sines and cosines. So actually this one only has cosines, but the instructions will be very generic, only sines and cosines. Alright, so let's move on. And what we're going to do here is express this difference as a product. So now I need to look at the other side of those equations. I need to look at the difference and find a good product for this. So cosine of alpha minus cosine beta, here's my equation. Does my alpha and beta matter? This time it really does. I can't switch this cosine with this cosine. So this one, it really does matter. You can't switch these up. Don't do it. That's why I suggest you don't mess with it. Plug in your first angle for alpha, plug in your second angle for beta. Just don't mess with it. Okay, so we go ahead and plug in the 5 theta and the 3 theta for our alpha and our beta. And then I just need to simplify. And obviously I can take it one step further with this. All right, there we go. So there is our answer. It's a product of sines in this case, but depending on what they give you, you might be writing a product of cosines. So now let's establish this identity. Now this one gets pretty hairy because these equations start out pretty big and then we do some simple simplification to get them easier. It looks scary, I'm not going to lie, it does. So I go ahead and I plug in my 4 theta as my alpha, my 8 theta as my beta, and I'm going to simplify. Not too bad, it's starting to get easier, but notice these will cancel. So whenever you've got something top and bottom, go ahead and cancel them. I can cancel these 2's, I can cancel these sines. I can't cancel the sine of 6 theta and the cosine of 6 theta. I'm going to need those suckers, so I don't want them to cancel. And now we're down to cosine over sine, which we know is cotangent. All right, that was a lot of stuff to cover, but it's time to get to work. I'll see you in class, and I'll see you online.